Hello, and welcome to Ants Are Everywhere. We're taking a look at Serenity, the operating system, the retro-style operating system. We have C++, mostly C++, 88.3%. There's some JavaScript, a little tiny teensy bit of C, and some shell and stuff. And this used to be a one-person project, I guess, the same way that Linux used to be a one-person project. And I'm pretty sure I read on Hacker News recently that the guy who started it is splitting off to focus on the browser. Ladybird, I think, is the name of the browser. We are going to restrict this to 30 minutes. And that's going to really make it so that we are not going to see a lot of the most important stuff. This is going to be a whirlwind tour. But that's what we're doing. It is what we're doing. So I shall start my timer here. After I have a sip of the old Java juice. Okay, so this is an operating system. So we have a kernel, and we have userland, and we have Ladybird. And Ladybird is on the same conceptual level as the kernel and the userland. I think that is probably reasonable. If you were to build an operating system these days, so much of operating system is windowing, and you could imagine heavily relying on the browser for windowing. In fact, I'm pretty sure that's what Microsoft tried to do in the famous Microsoft trial. And they were told that the web browser, I think they were essentially told that the web browser is not an essential feature of Windows, and that they should allow other browsers. All right. I don't know what AK is, and we also have base. So base is presumably going to be the kind of classes and stuff that are shared by all the things. These are named after the Unixy directories, like etc. Home anon is maybe like anon is perhaps the default user, or just an anonymous user. I don't know what res is, but we have a root, presumably the root directory, or maybe the root user. User share in www. AK has what? I see some big int stuff. Badge atomic. Badge might be like notification badges. I don't know. It's a binary heap, binary search. So we have some algorithm stuff. We have some async stream stuff. These look like libraries, kind of. Checked. Checked what? Checked, I don't know. Circular buffer. Concepts. Let's look in concepts. DOS packed time. Demangle. This may be, I don't know what we're demangling. Some endianness. Yeah, these are this seems like a kind of a utility folder. And I don't know why it's called AK. Maybe just to have a nice short namespace. In concepts, we have like is integral, is floating point. Oh, no. We have things, so the concepts are things like integral, signed, unsigned, enum, one of. What on earth? Hash compatible. Is concept a C++ thing? Constraints and concepts since C++ 20. Okay. Yeah, I think I was not using C++ 20. Name sets of such requirements are called concepts. Each concept is a predicate, evaluated at compile time, and becomes a part of the interface of a template where it is used as a constraint. So this is like constraints on metaprogramming. And that's cool. But that's not so informative about SerenityOS. Okay, so we have Ladybird, and we also have kernel, and we also have userland. And we have 30 minutes. Should we devote 10 to each? Probably not. Let's maybe look in kernel first. What do we want to see? I'll open up system calls. Unix types, is that interesting? I'm not sure. Is tasks, is pre-kernel interesting? We have random, some boot stuff, init, kmalloc, a linker, and multi-boot. And some assertions. That is possibly interesting. What is the API? So we have file system stuff, POSIX. What do you have to implement? So we have FAT. Is maybe the only implemented file system? I'm not sure. We have events, like a device event, a beep instruction. What's going on in POSIX? We have net inet. So this should be interface, route, whatever net inet is. This is like TCP. Look at the TCP header. We have a few texts, some support for polling, a scheduler, I assume, some Serenity header, signal, standard IO, time, uContext, etc. So maybe API means headers. And what about locking? Lock rank, lock mode, lock location, mutex. Let's look at mutex. Let's look at spin lock header, just for fun. How about bus? PCI, serial IO, USB. Should we look at PCI? I guess we'll look at definitions and device.cpp. And maybe API.cpp. And we'll open up some stuff for USB as well. USB classes. Yeah, how about UHCI controller? And we'll just open a smattering since we have limited time. I think I opened syscalls. What about tasks? Core dump, crash handler, futex queue, power state switch task. We'll look at process and process.cpp. Some of these CPP files, I think I'm just going to schedule, close immediately, assuming that we get what we want to get out of their header. But we'll just open these here and there. And that will be the kernel queue. Let's open a userland queue. Userland has applets, like audio, key map, network, etc. That's possibly interesting. Possibly not. A dynamic loader, some games, libraries, services, shell, and utilities. Shell might be like a command line shell, or it might be a shell in a more general sense. We'll look at some of these. Shell.h. Maybe we'll look at libraries. libc, libarchive, libcpp, libgpu. I guess I want to see libc. Why not? ARPA, net. How about what do I want to see in libc? Yeah, sure. We'll look at semaphore. And I guess we'll open up Serenity.h and Serenity.cpp. And maybe some dev tools. Hack Studio Profiler. Actually, his demo is interesting. Eyes. Yeah, we'll look at eyes and we'll look at cat. Dog. What was it? Cat widget? Cat dog? Cool. So that'll be our userland queue. And then I guess we might as well open a Ladybird queue. Although we're not going to get to all of this stuff, obviously. So we have web workers, web drivers, request server, Qt, image decoder, icons, AppKit, UI system. I'm not sure where the hard work of the browser is being done. And I don't know if AppKit is like WebKit. AppKit is a graphical user interface. Initially served as a UI framework for next step. All right. So back to Ladybird, we have web content, web driver, web worker, CMake, and a bunch of other stuff. Let's move to some other repo. And it's built on the libweb and libjs engines from SerenityOS. And it has a cross-platform GUI and Qt 6. And the AppKit is for the Mac-specific GUI. The web rendering engine is libweb, which, where did it go? It's in userland library, so let's like pop that over for userland queue, which is back here. Okay, so let's just process from some of these queues and see where we get. Here's TCP. In POSIX netnet. So this may call out some other TCP file, and we get nothing. It's literally nothing. We're just setting TCP no delay and max seg. And that's all. That's all there is. Well, that's a letdown. Let's see if there's a more interesting TCP implementation. We have kernelnet TCP socket. Let's look in kernelnet TCP.h. TCP in all caps. And this is C++. So we've looked at the TCP implementation in Linux. And Linux, I think, was all in C, like pre-C++ C. But this is at least an operating system in more modern C++. So there's some TCP flags, like fin, sin, ACK, etc. Those are defined in the standard. The option kind, SAC permitted, SAC timestamped, and etc. GNU packed. I guess this is maybe some GCC directive. And we have a TCP option, which has the option kind and the length. Yeah. Oh, this is the header. This is still a header, not a CPP file. Here's a TCP packet, again with GNU packed. And we have this should be just all the packet information: the header size, the source port, the destination port, sequence number, etc. The packet is really just essentially a C struct. I guess maybe that's what packed is for. They like pack it into as efficiently as possible, I assume. And then we have some callback template for each option, passing the callback. And we get the next option by taking this. I'm not sure what this is. I think it's the packet. And adding the size of TCP packet. So I guess maybe the options are after the packet or something along those lines. Or rather, I don't know. We ask for the payload, which is, I guess, the end of the options. And while next options is less than options end, we check if there's enough space for another option. And if there is, then we take the next option, cast it as a TCP option const star, and get an auto const star option. And if the option kind is the end, we return. And if it's a no op, we do nothing by just incrementing the next option. And I guess this is another like boundary check. We might return if it's a minimal length option. Otherwise, we call the callback, which was passed in. Okay, so we're passing in a callback and it's just iterating over the options and calling it on each one with some making sure there's a valid, well-defined operation on that option, etc. Okay, so that's a little bit of TCP stuff. And here's some polling stuff. This is just API POSIX. I'm assuming API/POSIX is mostly relatively lightweight, and not where the real implementation is done. But so for poll FD, you give it some file descriptor, and it has a short for events and R events. I don't know if it's counting the events or. And what is a revent? I don't know what a revent is, but it's something. And we have things like poll error, poll hang up, poll end value. I'm not sure what all that is, but it's pretty it must be POSIX-y. And then here's some thread stuff. This is really just defining some stuff. Minimum thread priority is 1. Low priority is 10. Normal is 30. High is 50. And max is 99. We saw in the Bitcoin source code, we saw that they, I believe, set the priority to low for some of the mining operations. I'm guessing that would be 10, at least in SerenityOS. I don't know if that's the standard across all of POSIXes. And they set the thread back to normal when the mining was done. And that would be 30 in SerenityOS. And here is serenity.h. We get in enum some defines like whether to purge all the volatile elements. And so in enum, like perf event sample. I'm guessing this is perf in the sense of, well, I don't know. Maybe this is for sampling for performance evaluation, but I'm not sure. But we also have perf event malloc. So maybe this is for performance stuff, and this is saying that like the perf event is that's the thing that's going on now. Maybe and so that we know like which cost sensor to attribute it to, page fault, syscall, etc. And then I guess maybe sample is possibly we are sampling the perf data itself, and that's that possibly incurs a performance hit not associated with not running perf. And then we get some more thread priority level stuff with the same definitions. I'm just mildly curious about this. This is probably POSIX related, right? Perf wiki. Yeah, I think that's probably more or less what it's up to. Here's mutex.cpp. This is in kernel/locking, and we're looking at a CPP file rather than its header. And we have what? Void mutex lock. So in C++, this means this is like the class is mutex, right? That's how C++ works. Yeah. Okay. I wanted to make sure I didn't see a class definition. All right, so the class is mutex, and you can call .lock on the class if you want to. You give it a mode and lock location with this maybe unused annotation. This may be one of the C++ 20 things, and I'm guessing this is just to prevent warning you from not using the location. And it's going to lock some stuff. Well, we have this verify thing. Processor current in IQ. Note, this may be called from an interrupt handler, not an IRQ handler, and also from within critical sections. So we verify, I guess, that we're not in IRQ. And then we are checking if we're in critical debug. And we're checking that we are not in, the mode is not unlocked mode. And then assuming all of those checks pass, then we will get the current thread and a spin locker. We're taking mlock, which is what? Maybe m. I think m might just be a prefix that means that it's like a local variable. Yeah. Okay. So we're taking the local lock. Oops. And passing it to lock, which I guess is going to give us a spin lock locker. We'll say did block is false. Set the current mode to whatever M mode is. And based on what the current mode is, we'll do a switch, the old switcherini. And if we're currently unlocked, then presumably we're going to lock it with some debug stuff, verify some stuff. And if we are, so mode is what we passed in as opposed to current mode, which is the state of the universe. So mode is what's being requested. And so if we requested exclusive mode, then we're going to bitcast the current thread uint pointer t. I'm not sure. I don't think this has anything. I'm not sure why we're doing that, but I guess this is going to give us an M holder. And what is M holder? M holder, I guess, is a class variable. And we're going to, that's some reference to the current thread. That is bit E. And otherwise, if we're not, so I guess we're just saying that, forget the bit stuff. We've been asked to have an exclusive lock, so we're just keeping track of which thread has it locked. Otherwise, we should be in shared mode. And so we're just going to increment the number of shared holders and add them somewhere. I guess add them to a map. We're going to map the current thread to 1. Why 1? Because I think we were unlocked originally. And then so down below, there should be some other code that says if we are currently in a shared lock, we're going to increment this. So in fact, let's see if we can find that code. Case mode shared. And if we're being asked for, if we are in mode shared and we are asked for mode shared, then we're going to verify some stuff. And I don't know. Here, I guess, is where if we didn't block, I think, then here's where we increment the thing in the map to indicate that it may have locked multiple times. Something along those lines. All right, here's spinlock.h. And this is in kernel/locking. It's not in the API POSIX stuff. So we have this lock, which is going to return an interrupt state. We're going to call this processor stuff. Processor enter critical. It's processor disable interrupts. That's presumably going to enter into the critical section or critical mode. It's going to disable interrupts. And while lock exchange, something about memory order acquire, AK was this kind of like namespace of utilities as I have interpreted it. We're going to check that this exchange is not 0. I'm not sure what that means. And then if it is non-zero, we're going to call wait check in a while loop. And then whatever that's doing, that's, I guess, checking some sort of sanity checking condition, I think, probably. And then we're going to call track lock acquire on M rank. I don't know what the rank is. And then we're going to return the previous interrupt state, which is the state of the processor before we disable interrupts. But we don't re-enable interrupts. And then when we call unlock, we verify that it is locked. We track the lock release. We store some stuff in 0 memory order release. And then we leave the critical section and we restore interrupt state. And then when we initialize, we call mlock store 0, aka memory order relaxed. Okay, so relaxed, yeah, I don't know. I don't know. I think this is maybe configuring memory order as opposed to telling the lock something about the external memory order, but I'm not sure. And we have a reverse spin lock, etc., etc. All right, let's just plow along. Here's bus PCI definitions. We have header type, which is a device or a bridge. Header type 0 base register. Latency timer, bar, secondary bus, etc. This is bus stuff. Open firmware address. How are we on time? We have 5 minutes left. I'm not sure. Not sure what to do. I guess we're going to kind of plow. Let's get rid of this. Do we care about USB? Maybe. I'm just curious about I don't know much about the USB standard, to be honest. So these are different device classes. You have audio, communications, and CDC control. CDC, is that like manufacturing or the Center for Disease Controls? We have image, printer, mass storage, hub, billboard, audio video, diagnostic wireless controller, and vendor specific. And then we have this UHCI controller where you can initialize, stop, start, spawn, async, poll process, etc. Okay. Here's task process. I'm just gonna kind of go through this. I'm curious about scheduling. We have total time scheduled. This is just keeping track of the total time scheduled. We have a scheduler, which has things like yield, pick next, timer tick, prepare for idle loop. Hi, Aiden. DQ runnable thread, dump scheduler state, add time schedule. It doesn't really tell me about what the scheduling algorithms are. So maybe that's in a separate file. I'm not sure. Maybe this scheduling algorithm is just kind of like built into this file. How about we search for round robin? How about we search for Robin? Robin Hood, probing. Yeah, I don't know. Moving along though. This wait queue, we'll ignore the rest of that. We'll mostly ignore userland, but let's get a little bit of a look at libweb. That seems to be one of the things that they've... it's hard to make a web rendering library. It's only like 2 of them that are really used a lot. And so we might as well give them at least a quick peek. And I don't know what in the 3 minutes we have left, what the most important stuff is. We have WebSockets. I don't think that's a big part of it. XHR and XML, maybe. Traversal decision, pixel units, tree node. I think a lot of the, probably a lot of the difficulty is getting all the quirks right. So like browsers evolved over a long period of time when people basically had no idea what they were doing. And so you have to kind of make sure that everything looks and feels right. Here's DOM. In DOM, we have things like abort controller, abstract range, accessibility tree node, character data, child node, custom event, DOM implementation. Let's look at DOM implementation header, document observer. Let's look at that. And element and element.cpp, and that'll probably take up all of our time. In HTML, we have canvas and an event loop. Those are good things to see. XHR, I don't even remember what it is. Yeah, HTTP request event target. Now let's look at one of those. And we have a traversal decision, which is just continue, skip children, and continue or break. Okay. So painting, we have affine, command executor, border painting, border radii. So this is painting stuff. We've seen some 2D painting stuff, but really not a lot. We've seen more 3D graphic stuff than 2D painter stuff. XML I'll skip. CSS I'll skip. We'll look quickly at DOM implementation. And what do we have? Initialize visit edges. You pass in a JS realm. I guess that's like the JS root thing. I don't think they're using V8. They have maybe their own JavaScript thing. And we have a document. And really, that's about it. let's look in document observer.h. It's a platform object, and we have a web platform object and a JS declare allocator. And so we have things like document became inactive, document completely loaded. Inactive, I'm not sure when that's called. Maybe you put it, you've have highlighted another tab, so this is in the background, something like that. And then document completely loaded should be when all of the things load. And then we have some document observer stuff, and we have visit edges and finalize. I think I just opened the headers, right? Probably should have opened the CPP files, but we only have a few minutes left, so it is what it is. In element, we have shadow root init. So I don't know what a shadow root is. Maybe this is like the, do they call that shadow DOM, where you have like a virtual DOM alongside it? Maybe it has something to do with that. We have scroll into view options. And this is just some W3C standard thing, I guess, related to CSS. And we have an element has a parent node, a child node. So it's a tree, as you might expect. Whatever aria is, I forget what aria is. Aria is accessibility. Yeah. So Aiden, that's a good question. Let me get through these files real quickly while it's in my RAM here, and then I'll take a look at your questions. So we have tag name, prefix, set prefix. So there's really not a lot I think, to get out of the header. Insert a JSON HTML, outer HTML, inner HTML. But I mean, this has a lot of stuff. Aria hidden, aria level. Okay. Parent element. Yes, this is a pretty complicated class, the element class. Here's element.cpp, which I'm not going to really look into since my timer went off. And then here's request event target. On load start, on progress, on abort. Yeah, I'm not sure. All right, well, that's a really quick breeze by the SerenityOS. As I said, these are limited right now to half an hour, so we're just getting a whirlwind tour. And for many of these, we want to see more. We can always come back to them later. As I've said recently, all of the requests are on pause until, or rather, I'm not taking new requests until I process this backlog. But once the backlog is done, I'm going to have a new system for making requests, figuring out which order to do things in, and all that good stuff. So let me take a look at Aiden's question. I'm a first-year BTech CS student, and I'm confused about both open source contributions and CP. What do you mean by CP? What should I prefer more to focus on to get good placement, kind? Open source contributions and CP. A good placement. It's a good question. I don't know what CP is. Once you tell me what CP is, I'll be able to hand to competitive programming. I don't think you should focus on competitive programming. I think competitive programming is probably cool and it's probably fun, but I don't know that. I don't think they're going to weigh that very much in getting a job. What they will weigh more is some sort of demonstration that you know how to build things. And competitive programming is, because it's so time-bound, you're focusing on smaller problems than you typically would be in like a large organization. And also, you're just trying to hammer it out. just try to hammer it out so fast. And that's a different thing than most people are doing. That's different than the vast majority of people are doing in a place like Google or Meta, or I don't know if Snap is still around, or whatever place people are working at. You do need to do like programming exercises like leak code. I don't know if that's what you mean by competitive programming. I'm imagining competitive programming as the kind of CS equivalent of like math competitions, like the Putnam competition in math, where you have a team and you're like trying to get the fastest bit manipulation algorithm for some specific problem. That said, if you like love competitive programming and you're like super passionate about it and you can't live without it, I think that sort of thing will shine through in an application, and they would probably find a place to put you where those sorts of like low level optimization skills are needed. But just in terms of playing the numbers game, like the typical student who had to choose between where to allocate their time, between those two, I would allocate it more toward open source contributions, I think.